This is the fourth and final video on using integration to find the volume of solids created when you're rotating a curve around the x-axis. We're going to have a look at the exam question, which looks like this. So we've got a curve C, given by this equation. We can see that we've got a tangent to that curve at the point 1, 2. The tangent cuts through the x-axis at point 3, and that's forming this region here, R. And we're told we need to find the exact value, the exact volume generated by R when it's rotated 360 degrees around the x-axis. Now, so I've got this region R. If I was to use the formula, the usual formula that we've seen in the previous videos, if I were to use that here, that would tell me the whole volume of everything underneath this curve. So that's not going to tell me just the volume created by R, that's going to tell me all of this over here as well. So we need to be a little bit careful here, because I don't want to include this shape here. Well, what shape would be created by that? If I've got this triangle here, if I was to rotate a triangle around the x-axis, you ever think about what shape that would form? If I was to rotate this triangle around the x-axis, if I have a triangle like that, if I rotate this triangle around, what shape do you get? Maybe if I do it this way around, it'll be a bit more obvious. Hopefully you can see you get a cone. If I was to rotate this around, you get a cone. Now, that's fine. We can use our formula. We can work out the total volume created underneath the curve, and then subtract the volume of that cone. So, that's what we're going to do. So let's work out the volume to begin with of everything. So the volume is pi. The limits are 1 and 3. My y function is this. Squared with respect to x. Okay, right, we can actually, we can simplify this quite easily. Just looking at what's inside the brackets, I've got the x divided by x, which is 1, and then I've got the 1 divided by x. So if I write it like that to begin with, and then if I multiply out the brackets, that would be a 1. I'll have a 1 times 1 over x times 2, and then I'll have a 1 over x squared. Now in terms of integrating this is easy to integrate, this is easy to integrate. I just need to rewrite this as x to the power minus 2. Okay. So, the 1 will integrate to x, the 2 over x will integrate to 2 ln x, and the x over, the x to the power minus 2 will integrate to b minus x to the power minus 1. Put my limits in. So the volume would be 3 plus 2 ln 3 minus 1/3, and then I need to put the 1 in as well, so subtract 1 plus 2 ln 1. ln 1 is 0, so 2 times 0 is 0. Then I've got my minus 1 to the power minus 1, So 1 over 1 is 1, so I've got a minus 1. Okay, well this disappears, so I just get left with 3 take away 1/3, which is going to be 2 and 2/3, or I could say 8 over 3 plus 2 and 3. Right, that's the volume of everything underneath this curve now. Let's look at the volume of the cone. Let's do that up here. So the volume of the cone. Now, if you're lucky, you'll be told the formula. The formula is 1/3 times pi r squared times h. That's the formula. To be honest, I've not seen an exam question where they've not told you that formula. Hopefully you'll be given it. It's probably worth you learning it anyway. You should have seen it when you were doing GCSE anyway, to be honest. So in this case here, what's going on? We've got 1/3 times pi. The radius of the cone, well, that is this. This is your radius here. That's the thing that's getting rotated around. Now that radius is 2. The height here is 2. So we've got 2 squared, and the height here, the height of the cone is 2. So simplifying that, we've got so that's 8 pi, so 8 over 3 pi. So my final answer then will be the area underneath the curve minus the area of the cone and I think actually in this case this is going to cancel with this, and so I will just get 2 pi ln 3 as my answer.